Hi all, I'm Divya. I'm working as an assistant professor at the Department of Biomedical Engineering at Sri Shanmuga College of Engineering and Technology. Today, I would like to present the topic Combinational Circuits, the building blocks of digital logic. I would like to make a big claim today. Without combinational circuits, the digital age as we know now, it would not exist. No computers, no laptops, no smartphones, no modern electronics. Let me show you why. Have you ever wondered what is inside a calculator? How it performs arithmetic operations like addition and subtraction and gives you answer instantly? Yes, the answer for your question is combinational circuits. So combinational circuits are digital logic circuits where the output depends solely on present inputs. It does not depend on the past conditions. So it performs arithmetic or logical operations instantly and gives you answer immediately. So these are all act as foundational building blocks in digital system design. So this is the block diagram of combinational circuits. We can partition this block diagram into three parts. So first one is input part, and the next one is processing unit, and the next one is the output part. So input parts, you can see the input lines here. You can see the input lines here. So these are all input lines where we can place the inputs which we need to process with the help of the combinational circuits. So the next one is this block is the combinational logic circuit, which is also known as the processing unit. So which is the main part of the circuit which will process the inputs what we are given and generate the outputs. So this is the output part, so which is these are output lines where we can take the output from the combinational circuit which was processed with the help of the processing unit. The next one is key characteristics of combinational circuits. No memory element, right? So there is no memory element present in the combinational circuit. So there is no need to save the past condition. Only the current input matters. No feedback path. There is no need to feedback the output into the input. So the circuit is a simple forward logic circuit. And the next one is deterministic output. So deterministic output means for the given set of input values, the predetermined and uniquely predicted output will be given. So the output will be deterministic one. And since there is no memory element, no feedback path, there is no need to process the past conditions and no feedback release, the output will be instant and will get the faster response. So the next one is types of combinational circuits. So the first type is binary adders. So it is a combinational circuit that performs the addition of binary digits or bits. So binary adder is a combinational circuit that performs the addition of the binary digits given as an input. So again, we can classify the binary adders into half adder and full adder. So the first one is half adder. Here we can see the block logic symbol of the half adder. So in a half adder, we can give two input. We have two input lines, so we can give two single digit binary numbers. So the half adder is the combinational circuit which process the inputs two single digit inputs, and it will produce the two outputs carry and sum. So here we can see the truth table of the half adder. So here we have two inputs, two single digit inputs. So there is only two single digit inputs. So totally four combinations we have. Totally four combinations we have: 0 0, 0 1, 1 0, 1 1. So if you add 0 plus 0, 0 plus 0 is 0. So the sum will be 0 and the carry will be 0. So 0 plus 1 is 1 and the carry is 0. 1 plus 0 is 1 and the carry is 0. 1 plus 1 is 1 0, right? So the sum is 0, the carry is 1. So next one is we need to draw K map for the carry and sum. For carry and sum, in order to write the Boolean expression, So for carry, first we need to write for carry. So this is a two variable K map. We have only two variables as input. So it is a two variable K map. So you will have only A, B. So if it is a two variable K map, we will get 2 power n, which is equal to 4 boxes. So you have to write the carry values, which is 0 0 0 1. So 0 0 0 1. Next thing is for sum you have to write the values as 0 1 1 0, 0 1 1 0. So this side you have to write as 0 1. So this 0 means A bar and 1 means A. Here 0 means B bar and 1 means B. Next you have to map the ones. So here we have only 1 1. So you have to map it as a single. So here you can find here what is the variable A. Here what is the variable we have? B. So you have to write as AB. Here we have two ones, but we cannot map it together. So we have to map it individually. So map this one individually and map this one individually. So if you write variable for this one, so here it is what variable we have? A bar. Here B. So A bar B plus for this one A B bar. A B bar. So A B bar plus A bar B can be written as A XOR B. Next one is we need to draw the logic diagram. How can we draw logic diagram? So for sum, we need to draw an A XOR B. So A XOR B. So this is the logic symbol of the XOR gate. So A XOR B will give the result as sum and carry A and B. A and B will produce the carry A and B.